integral of sine is negative cos x. Negative cos x, then plus a constant of integration. And this one eventually gives us x sine x plus cos x plus a constant of integration. And this one becomes the answer for the integral of x with respect to x. Basically, that is how integration by parts operates. Someone has a question?
Yes, sir. I have a question. Now, you stated it earlier that when you are to approach the number using the integration by part, you have to be critical and then identifying the function that can easily be differentiated and also be easily integrated. So when you look at these two functions now, when you take cos to be u, it can also give you the du of cost. So can we get the same answer if I'm to use to take u as cos of x?
If you take u as cos of x,
Yes.
Let's try it here. So if I take u to be cos of x, correct?
Yes.
I'll get my du to be
sine, negative sine.
It is negative sine x.
Yes.
Then if I take my dv to be x, you will get x squared over 2. So definitely you're going to get, I think you're going to get a different answer.
Different answer.
It is going to be a different answer, but let's complete it and see before I can give my response. Okay, so here I'll get the integral of u dv, which u is the
cos of x.
Cos of x dv dx will be uv. uv, which is going to, oh, no. It is going to be uv, which is cos x.
Yes.
Minus the integral of v du.
Negative sine.
Negative sine x. Can I do this?
Yes.
Dx. You're going to observe something here. This is going to give us x squared over 2 cos x plus a half integral of x squared sine x dx. Now,
taking us another integration by part.
So it is so it is still going to take us in the same loop, and we shall end up integrating forever.
Okay.
So the choice of which one is u and which one is dv is something very, very important. We want to choose a function. Okay, when you're choosing, you're as well looking at this guy, the v du. You see, when I make a u to be x, my du is dx. Ideally, I'm dissolving the x. I'm dissolving this function. So it is not a matter of looking at which function is easier to differentiate and which one is easier to integrate. But at the back of our minds, we must also look at the other side. We need to have one of the functions actually dissolve. We must have one of the functions dissolve. If we don't do that, we might stay in a continuous loop, like the scenario we are seeing here. Hope that makes some sense.
Yeah, it is.
Okay. Yes, someone is asking a question.
No, Mr. Chimera, you were saying the last one doesn't make sense.
Yeah. This one.
Yeah.
Eventually, you might get to the same answer, but after a number of iterations. You might get to the same answer, but after a number of iterations, which we want to eliminate. We can have another example maybe and see if it is making sense to us. Okay, let's try out this. Let's try out this. Insert a new blank page. Okay. Let's try out this. Let's integrate. Um, let's integrate. Let's integrate. Oh, sorry. Here. Let's integrate x. Let's integrate x e power x with respect to x. I can give a hint here. Let your u be equivalent to x. Let your dv be equivalent to e power x. Let's consider those very fast and see if we can get an answer. Let's try getting an answer for that. Yes, has anyone got the answer?
Yes,
Uh-huh.
it is xe raised to power x.
Wait a second. It is xe
E raised to power x minus e raised to power x plus c.
plus c.
Yeah.
Okay. Any different answer? Has someone got the same? Anyone with a different answer or anyone with the same answer?
I have the same answer.
Okay. Great.
Same here.
Great. That's the answer. Those 4 people are good. That's good enough to consider. Okay. One last example. Find the integral of x squared ln x dx. Let me just give an open check and see what people get, what considerations they'll take. All, actually, that one will be exercise later. Let's do this one. X squared e power x dx. You do this one in your free time. Find this. Now I'm not giving a hint. Let's see what people will want to consider as x. What people want to consider as u and what people want to consider as b, v. Okay, I'm holding here. We need to see what answers people get.
It's quite complicated. I have some idea. It is x square.
You've got the answer?
I think I'm not sure of it.
It is okay. No worries. We can put
X
here.
square
You're getting x squared. Wait, let me get my pen here. We get x squared e
ex.
x.
The it is the power of it. Yeah, like that. Minus 2x e raised to power x
2x e power x.
power x. Then again plus 2ex
plus 2e x, something like that,
plus c.
plus c. Okay. which can be simplified as x squared e power x minus 2ex into x minus 1 plus a constant of integration. Correct?
Yeah, I don't know.
That is the simple part, like when you factorize out.
Okay, sir. Is it okay, like, to go through that number? Because I'm not getting it. I'm getting a wrong answer here.
Okay. It is okay. Someone who has got it right, please, I'm becoming your secretary here. So be telling me as I write, step by step.
Mr. Chimera, I need to submit my answer also. I'm getting x squared I'm not writing. E squared
X squared?
Yeah, e squared minus 2xe squared.
E squared?
Yeah.
Like this, e power 2?
Yeah.
We
and
don't
it's
have
confusing.
that.
It's confusing me. Sorry, just a second. let me
Mr. Chima, let me submit mine too, we see. This is Dumba. May I share?
Please share.
May I've got x squared ex minus 2x ex plus a constant.
Okay. Let's try to go through it. Let's try to go through it together and see. We have a number of answers there. We can, so this one, we want to find the integral. We want to find the integral of x squared ex dx. Ex squared dx. Okay. Which one are we letting u? Which one are we letting to be u? Which one are we letting to be dv?
X squared. U squared, x squared.
I'm happy everyone is mentioning the same. Let u be equivalent to x squared, meaning my du is going to be 2x dx.
Yeah, agreed.
Okay. Then that means my dv is going to be ex. Okay,
then
and
dx.
this implies that my v is ex.
Yeah.
Yes.
Are we together?
Yes, sir.
Remember, we are saying u dv equals uv minus the integral of v du. The integral of x squared ex dx equals uv. uv. My u is this, my v is this minus the integral of v, okay, which is this, correct?
Yes.
Then dv, du, sorry, my v is this, then du is 2x dx. If I reorganize
Yes,
this,
sir.
I'll get x squared ex minus 2 outside the integral of x ex dx. Okay, so we can still subject this one to integration by parts, with our u being x and my dv equals ex. Okay, and actually we have already got that one from the previous answer.